You try the third part?
No, ma'am, not yet.
So then let's do it together only. So you have understood the first and the second part, or should I repeat them?
Understood, ma'am.
Then let's do the third directly. See, in the first part, we had calculated the time period of oscillation. In the second part, we had to calculate the time when the amplitude dropped to half of its initial value. Now we have to find the time when the mechanical energy drops to its initial half value. So see, this was the relation of energy that we did. E prime is equal to E exponential to the power minus Bt divided by m, not 2m. 2m was there in case of amplitude. So E dash is equal to e to the power minus Bt by m. So what is the value of E prime that I should put? Yes, what is the value of E prime that we should put? What is the final value of energy that is? Yes, Akifa, are you there in the meeting?
Yes, ma'am.
Look at the question. It says time taken by mechanical energy to drop to half of its initial value. If E is the initial value, then what should be the final value?
E by 2.
E by 2. So E prime would be what? It would be simply E by 2. That's how you have not revised anything.
No, ma'am, I had chemistry exam today.
Okay, so fine. See, in the last class also, we did this. If amplitude was dropping to half of its initial value, then we wrote, instead of A prime, we wrote A by 2 because it dropped to half. So similarly, now everything is similar to the previous part. It's just that energy has dropped to half its value. So we'll put E by 2. So it will be E by 2 is equal to E to the power minus Bt divided by M. So E will get cancelled. As I've told you yesterday also, to make the power positive, we can take the reciprocal of it. So it will be E to the power Bt by M is equal to 2. Also, I've told you that whenever we have to remove exponential form, we put what? Do you remember?
Log.
Log. So it will be ln E to the power Vt by M and ln 2 over 4, means log on both the sides. So log 2 and then log E to the power Bt by M. Also, whenever you have exponents in the power, then the power comes out as constant. So this will be simply Bt by M is equal to ln 2. So from here we can calculate the value of time. We have to find the time taken. So time will be equal to what? Time will be equal to m multiplied by ln 2 divided by b. So log 2's value I have told you yesterday also. ln 2 is equal to 0.693. So time period is equal to mass is 0.2. Log 2 is 0.693 divided by b. Constant is given to us as 0.04. So time this will be half. Okay, this will be 6.93 by 2, this much. Is this clear now?
Yes, ma'am.
Okay, so just add this, write this third part also in the notes.
Done now.
Okay, so see, we had seen few systems yesterday. Spring mass systems, simple pendulum system also. Now see, few systems are still left. Oscillations of floating cylinder. Okay, before this, one more thing. See, when SHM is as projection of uniform circular motion. When SHM is as a projection of uniform circular motion. See, if this is the main axis, this is the y-axis, this is the x-axis. This is the y-axis and this is the x-axis. Now see, if I write x is equal to, let's say the amplitude is r. This is cos theta plus phi. So we have to represent this equation on this. See, amplitude, you know, the maximum value of the displacement produced is known as the amplitude. So this is the wave. This distance covered is known as the amplitude. So if I have to plot this equation graphically on this diagram as a projection, so what will I do? This will represent my R. R is what? R is the amplitude. So amplitude will be represented like this. This is the amplitude. Let's say this is some value of amplitude. So this will represent our theta. Theta is the total angle that is produced. Let's say this is the phase constant. This is some phase constant phi. So theta is this total angle produced is known as theta. So whenever you have to represent it through, see, it is sometimes quite helpful to analyze SHM in terms of uniform circular motion. So we say, suppose a particle is moving with a uniform angular speed in the circumference of the circle, like this. This is the particle, it is moving in the circumference of the circle with, let's say this is the radius. Let's say this is the radius, small. And it is moving with what? Omega. Omega is the angular speed, angular velocity. So if we have to display it graphically on this phasor diagram, we write it as x equals to r cos theta plus phi. How we draw it? This, if this is the amplitude, r is the amplitude, and then total angle is theta, and omega is what? Theta divided by t. That's how we write any other value, like y is equal to r sine omega t plus phi, because omega is equal to theta by t. If your rotation is anti-clockwise, you can draw it on the circle, and if it is clockwise, then you can simply reverse it. Fine, you just have to, like a particle traveling around the reference circle of radius a at constant speed. What is the speed? Omega, and omega is equal to 2 pi. Omega is equal to 2 pi. So it can be used to represent simple harmonic motion of the amplitude capital R with the frequency mu. Clear?
Yes, ma'am.
And this circle is known as the reference circle, which represents the simple harmonic motion. This circle is called the reference circle of SHM. Okay, just note down this, then we'll do the other systems left. Done?
Almost.
Don't know. See, one of the topics that was left yesterday was YouTube, oscillations of a not floating cylinder. First, we'll do YouTube, oscillation of a liquid in YouTube column. Of not floating cylinder. H2, oscillation of liquid in U-shaped tube. Now see, as I've already drawn it, we have to consider a liquid filled in vertical U-tubes. These are the U-shaped tubes of uniform area of cross-section up to, let's say, height h. So h is the height of this vertical column as well as h is the height of this vertical column. So if h is this and h is this total length becomes what? H plus h, that is 2h, right? So see, initially we say the liquid level is at equilibrium position. In equilibrium position, the liquid level is at the same height in both of them. If the liquid is at, let's say, 10 centimeter from the bottom, then it will be at 10 centimeter from the bottom as for this second one also. Now see, if we press one down, if we press it from one side, what will happen? Let's say if I apply force from this side over this side, this will rise a bit. Level in the second arm rises up to certain distance. Let's say this certain distance is small y, and the distance to which is it has depressed. This distance is also small y. So if I apply force over this side on this arm, if I apply force on this arm of the U-shaped tube, then the level of liquid will rise in this column. Yes or no? If you apply force over this direction, all the liquid will be pushed from the next arm.
Yes, ma'am.
So see, when pressed, the level of liquid is left free. Then what happens? When it is left free, the level of the liquids in the two limbs will oscillate. If you are holding it, if you are applying force to it, then this will rise up. But once you release it, once you release the force and this is left free, then what will happen? This will go down, this will come up, this will go down, this will come up, and it means it will be oscillating to and fro like this. It will execute oscillation, oscillatory motion. The level of liquids in the two limbs will oscillate about their respective initial or the undisturbed position. So it will oscillate over this point like this. This will come up and then it will go down. So that's what we call oscillation of liquid in U-shaped tube. Now see, just to calculate, like we have calculated it for simple pendulum, we have calculated it for spring mass system, we have seen different values of constant. What remained constant? F is equal to minus K of X. This was the main equation. Whatever extra constant came were a part of this. If you remember, we have done the value of for simple pendulum as time period as 2 pi under root L by T. Yes or no? And for spring mass, what did we do? Yes, Akifa, do you remember the formula for spring mass system? T is equal to 2 pi under root M by K. That is for the spring mass system. For simple pendulum, it will be 2 pi under root L by T. So for liquid in U-tube, we have to find out this value of this constant K. See, if the length is 2h and I say area is A, density of this water or whatever is the liquid filled in the U-tube, this is rho. So for this U-tube, the volume of this U-tube will be what? Area multiplied by the length. So if area is A, length is 2h, then the volume of U-tube will be what? Area multiplied by length, A into 2h. And mass will be what? Mass will be volume multiplied by density. See, density is equal to mass by volume. So mass will be what? Density multiplied by the volume. So this is the volume, this is the density, this will give me the mass of the liquid. Mass of liquid present in the U-tube. Now see, if I say by y it has been depressed over this side, and by y only it will rise up from this side. So level of liquid is depressed in left arm by y, and it is raised by small y, and liquid will oscillate over. So see, total length, total extra length becomes what? Y from this side as well as y from this side also. So it's y, or will it be 2y?
Y.
See, one y is from this side and another y is from this side as well. Total length from here will be what? Simply y,
2y.
2y. It will be 2y, double of it. Because by y it is being depressed from this side. And by the similar amount, y it is being raised. So the total length, the level filled in length, 2y will be because of the total oscillation produced. Now see, this 2y length, this extra length that we are getting from both the tubes, this will offer a restoring force. Now we have to find the value of that restoring force. So F is equal to, F will be what? mg. So it will be, F will be equal to 2a rho gy. The rest of the terms are mass. We write F is equal to as mg. And m is what? Mass we have seen. Mass is basically Ma2Hg. A2H rho. This is the mass, and density and acceleration due to gravity is small g. So what will be the force? F will be equal to minus 2a rho gy. Now see, as I've told you, what is the standard equation for SHM? The standard equation for SHM is minus k of y. So every other term apart from this minus sign, this y, this f will be my constant. So this is the constant that I'm getting, 2a rho g. So see, the time period's value was 2 pi under root m by k. Now I will substitute the value for m, for the value of k that I've got. So on substitution, the final value of time period for the oscillation of a liquid in a U-shaped tube will be 2 pi under root h by g. Is this fine?
Yes, ma'am.
All right. Now see, this is the case of oscillation of a floating cylinder. See, I have considered, let's say a wooden cylinder is there, the mass of the cylinder is m, small m, a is the area of the cross section, and it is floating in a liquid of density sigma. And the density of the cylinder itself is rho. Rho is the density of cylinder, sigma is the density of the liquid. See, at equilibrium, the cylinder is floating with a depth, let's say y. It is floating with a depth y. And then what happens? The cylinder is floating with depth submerged. The cylinder is pushed downwards. If we push it downwards, if this cylinder is pushed downwards by some external force, let's say, then what will happen when once it is released, once this external force is removed, the cylinder will move up and down with simple harmonic motion. So it is desired that, or it is, we can say that it will be oscillating. Once the cylinder is released, first it is immersed, it is submerged a bit, then it is released. After that, once it is released, it will move up and down, and this motion, to and fro motion. What is this to and fro motion known as?
Oscillation.
Oscillation. So that's why a floating cylinder also executes simple harmonic motion. Now see, again, we have to find out the time period and frequency. So see, if I say, so when cylinder is further immersed by y, let's say this has been immersed by distance y. Now I have pushed it towards, and it has gone through a distance of small y. A is the area of cross section, L is the length of cylinder, rho is the density of cylinder, sigma is the density of the liquid. See, mass will be what? Mass will be again area multiplied by length will give the volume. This is the density, so mass will be A L rho. Again, F is equal to mg. So mass is what? This term is the mass multiplied by small g. So F is equal to A by sigma g. Now again, on comparing with the standard equation, F is equal to minus K of y. All the term apart from y minus an F will become the constant, the spring factor. So K will be equal to A sigma area multiplied density of the liquid multiplied by the acceleration due to gravity. Now see, we have the value of K. You can put it in this equation. P is equal to 2 pi under root m divided by K. K's value we have as A sigma J. And instead of m also, instead of m, you can put the value this AL rho. So once you will put it, P will be equal to 2 pi under root AL rho divided by K. K's value is what? A sigma G. A will get cancelled. You will be left with T is equal to 2 pi under root L rho divided by sigma G. Fine?
Yes, ma'am.
Then we have oscillation of a ball through the center of the Earth. See, suppose Earth to be a sphere of the radius, let's say capital R is the radius of it. And the center is O. This is the center O. Let's say we have a tunnel. Let a tunnel be dug along the diameter of the Earth, as I've shown over here. This is a tunnel that has been drawn. Now, if a body of mass small m, this body, is dropped at one end of the tunnel, let's say the first end, this is the first end, this is the second end. If this body of mass m is dropped at one end of the tunnel, then the body will execute SHM about this center O. Now see why this happens. We say because the body inside the Earth, only in the inner sphere of radius, will exert gravitational force. What happens? When the body will be over here, at the center of the Earth will be pulling it towards itself because of the gravitational forces. So it will move down. Once it will move down, then the center of Earth will be pulling it towards itself. Then it will go up. So this up and down movement again results in oscillatory movement. So when a ball is dropped in a tunnel passing through the center of Earth, then it will oscillate due to gravitational force of Earth about its center like this. It will move up, it will move down, up and down, all the oscillatory motion. Again, we have to find out the time period as well for this case also. See, you must have done gravitation in your first term where you must have seen this, the variation of acceleration due to gravity with depth, with height, with rotation, with altitude and all this. So see, this is the case with depth. So G prime is equal to G y by capital R. See, y is the distance that I have taken from the center. Let's say this distance from the center of the Earth is y. This small y is representing that distance. So see, G prime will be equal to G multiplied by small y capital R. This is all from your gravitational lesson. The derivation, just look up into once through your notes wherever you have studied this gravitation. You must have seen this relation. So G prime is equal to small g multiplied by small y divided by capital R. Now see, F is equal to mg. So we just have to multiply this term by mass. This will give us the force. This will come out to be F is equal to C. This is F is equal to m. Rest of the term Gy by capital R is G. This is F is equal to mg. And since restoring force is acting, we will put a minus sign. And all the terms apart from the minus sign, the y and the force gives us the value of the spring factor, that is the constant. So constant is what? This is mg divided by r. So see, if time period, the standard value of time period is 2 pi under root m by k. So time period will be 2 pi under root m divided by, instead of k, we can write mg by capital R. mg will get cancelled. It will be 2 pi r by. Are all the systems clear?
Yes, ma'am.
Hishma, is it clear to you? Yes, Hishma, you there?
Yes, ma'am.
No. So note down the
Ma'am, can you scroll?
Mom, can you scroll?
Done, ma'am.
Mom, can you scroll? Done, ma'am. Done, ma'am.
Both of you?
Yes, ma'am.
So that was all about oscillation. See the last chapter that is left. Hishma, when are your final exams starting?
Ma'am, it got over.
It is over already.
Yeah, ma'am. Today only I had physics.
So how did it go?
It was good and not that good, but yeah, it was good.
Many chapters you had to do on your own because
Yeah, ma'am, I did.
because
One more exam is left and then it's over.
okay. So now you don't have any, but your exam started so soon. It ended already in February. When did it start?
Ma'am, I think it started on 8th or something.
Oh, so comparatively you have joined a little late, no?
Yes, ma'am.
It's okay. Okay, so then let's start with waves, the last chapter of your 11th standard. See, these are just, you don't have to remember all these definitions. These are just basic definitions I have written because just to brush up your 10th, 9th, 10th concepts. See, wave transfers energy from one point to another, you all are aware of. Two types of waves exist, mechanical waves and electromagnetic waves. See, in this mechanical waves, these are those kind of waves which need medium to travel. So in mechanical waves, we have two types of other waves. In mechanical waves, we have first one is the transverse wave, other one is the longitudinal. The first one is the transverse wave, second is the longitudinal wave. When the particles of the wave vibrate about their mean position at right angle to each other, if they vibrate at right angle to each other, then we say the wave is a transverse wave. If the particles vibrate back and forth, like this, back and forth. Then we say the wave that is produced is known as the longitudinal wave. So basic examples are there, like ripples produced on the surface of water when stone is dropped into it, waves in the stretched strings of musical instrument when the string is plugged. Longitudinal waves, sound waves are longitudinal waves, and vibrations of air column in organ pipes are longitudinal. Organ pipes will be dealing. These are just the basic difference of these transverse wave and longitudinal waves. So the particles of the medium vibrate perpendicular, those are transverse waves, and which vibrate in the same direction, these are longitudinal. Since it vibrates it at right angles, so crest and trough are formed. Crest is positive part and trough is the negative part. In case of longitudinal waves, since particles travels back and forth, so compressions where particles are together and rarefactions where particles are apart, these kinds. And it can transverse wave propagate only in solids at the surface of liquid, and there is no pressure variation. In longitudinal waves, pressure varies. There are various values of pressure, and it can propagate in all of them. So these definitions you don't need to learn, you know all these definitions. What you need to understand, and also the wave terminology, these basic terminologies, you already know what is meant by amplitude, you know what is meant by wavelength, what is the time period, what is the frequency, what is the velocity of it. See, what you have to understand, and the topic that is new to you is how do we represent it, how a harmonic wave is represented. Harmonic wave. So particles of harmonic wave are in SHM. This is clear. The particles of harmonic wave are in SHM. Now the main part, how do we represent it? And you have to understand this part very well, because this is the most important part of this chapter, and other parts are related to it only. We'll be calculating velocity, we'll be calculating acceleration again for the particle now. See, the general equation of SHM, of harmonic wave, is A. You can use, as I've told you, it's sinusoidally it varies also, and it varies cosine also. So you can use cos also, you can use sine also. If I write sine, it will be A sine kx plus minus omega t plus phi naught. Now let's see what is meant by this. See, this A is the amplitude, which we have been dealing already. Sine or cosine, these are the basic trigonometric functions. This K is important. This is a new term in this. K's value is 2 pi divided by lambda. This is a constant, 2 pi divided by lambda. So wherever if you are provided with the value of wavelength and you don't know what is the value of K, just divide 2 pi by that value of wavelength, you will be getting this constant. X is the displacement produced. X you are aware of. Omega t phi naught. Rest of the terms you already know. Phi naught is what? Phi naught is the phase constant. T is the time. Omega is the angular velocity. X is the displacement. So see, now I have written plus minus over here. Why? When do we have to use plus? When do we have to use minus? You should know this. See, for positive, like when should the equation be like this? Y is equal to A sine kx plus omega t, and if phase difference is there, we can add up the phase difference also. But when do we have to use this positive sign? See, if the wave travels along negative x-axis or the negative direction, if the wave travels along negative x-axis, then we use positive sign. And if the wave travels along the positive x-axis, then we use minus. So for negative, this positive x-axis, the equation will be a sine kx minus omega t and plus phi naught, whatever is the phase constant. If the phase constant is absent, if it is 0, then we'll write it till here only. So how is the SHM wave represented? Harmonic wave is represented through this equation also and through this equation also. A cos kx plus minus omega t plus phi naught. What you have to understand is this: the value of k, that is 2 pi by lambda, and where we have to use plus and when we have to use minus, because many a times it is asked in the question by looking at the equation, identify in which direction is the wave traveling. So if this equation is of this kind, means you can see minus sign over here, then you can simply identify that the wave travels along positive x-axis. If it is plus sign over there, then it will travel along negative x-axis. So is this basic representation clear?
Yes, ma'am.
So before calculating particle velocity and particle acceleration, just note down this. I think you should note it from here. The previous terms or the basic terminologies you all are aware of. So write down this and we'll calculate particle velocity the way we have calculated wave velocity in oscillations. So Hishma, I think your result will come, I think, in March only, in the month of March.
What do you mean?
Your exams result, the result of this 11th standard, your exam that you gave, it will come in the month of March only.
Yeah, ma'am, because they said on 8th March they want to start the new academic year.
Oh, okay. 12th standard. Fine.
Done, ma'am.
Now let us calculate particle velocity and particle acceleration. See, particle velocity is different from the wave velocity. Wave velocity that we have studied in oscillations, SHM. That velocity, wave velocity, is the velocity with which the waves move, the velocity of the wave. But particle velocity is that velocity with which the particles of the medium vibrate about their inclusion. So the magnitude of their vibration, or whatever distance it is covering while vibrating in 1 second, you can say that is known as the particle velocity. So let's say equation of plane. Let's just take an equation of plane, progressive wave traveling in positive x direction. So if it's traveling in positive x direction, will it be minus kx or plus kx for positive x direction? Minus, because it gets reversed. For positive x direction, the main equation will be, let's take it as sine a sine omega t. It will be minus of kx. It won't be plus. This minus, if you are provided with this equation and if you have to identify the direction, you can simply look at this negative sign and say that this wave is traveling in positive x direction. Now see, this is y. Now we have to calculate velocity. See, in the previous calculations, when we were calculating it for oscillations, SHM, what happened? We didn't have this component. This constant was omitted. This constant was absent in case of wave velocity. Now we have this additional component. That's why the magnitude and the value of particle velocity won't be the same as the wave velocity. Wave velocity, if you remember, it was omega under root a square minus x square. For me, this was the wave velocity. If we take it for mean position, x will be 0, then v will be equal to omega a. And for extreme position, x was equal to the amplitude. So this got cancelled and v came out to be 0. Yes, Akif, I remember we have calculated the values of this. So see, now for the calculation of particle velocity, again we'll be differentiating it. So velocity will be rate of change of displacement only. So we have to differentiate this. This will be dy over dt. So this will be d, the whole term of y, a sine omega t minus kx over dt, the differential of this whole term, that will give us velocity. Now see, omega will come out as constant in differentiation. This constant comes out first. So it will be omega a, the amplitude will remain. For sine, it will be cos, and rest of the angle term will be the same, omega t minus kx. This is the velocity value. See, omega a, as I've told you, from this equation, a square minus x square omega. If x is equal to 0, v will be equal to omega a. Is this its maximum value or minimum value?
Maximum.
Maximum value. So we can say velocity will be v max cos omega t minus k of x. K. So see, v max is what? V max is equal to omega a. And we can write omega as 2 pi divided by t. This is the relation between omega and time period, 2 pi by t, and multiplied by the amplitude. So maximum velocity, maximum particle velocity will also come out to be 2 pi a divided by t, and the main equation is this, omega a cos omega t minus kx. So see, particle velocity is very simple harmonically with time. Wave travels with constant velocity in a medium. So particle velocity is a varying quantity, whereas wave velocity is constant for a medium. And the velocity amplitude is 2 pi times the displacement. This is the displacement, or you can say amplitude. So it is 2 pi divided by t multiplied. Now see, if we have to calculate the particle's acceleration, this was the particle's velocity. If we have to find out the particle acceleration. See, acceleration is differential form of velocity only. Acceleration is what? It is rate of change of velocity. So we have the value of velocity with us. For calculation of acceleration, we can simply differentiate it, dv over dt. So see, the rest of the terms for velocity was omega a cos omega t minus kx. Differentiation of this means differentiate velocity with respect to time. So this will be what? Omega a will come out. Omega will come this term. For here, it will be one of this. See, this is constant. Omega is constant. Now we have to differentiate this cos omega t minus kx. For differentiating cos omega t minus kx, this omega will come out, and the differential form of cos is negative of sine. So it will be minus sine and rest of the terms minus omega t minus k. This is what we have it for acceleration. So if we have to simplify it and write it, then it will be minus omega square a. This will be minus omega square a sine. This minus omega square is sine omega t minus k of. This will be the acceleration. And see, minus omega square a, if you remember, is the maximum acceleration. Minimum acceleration was 0. Maximum acceleration was minus omega square a. See, it will be confusing with this. I am writing the full form of acceleration because this a is not acceleration. This is the amplitude. A, the small a is the amplitude. So maximum acceleration would be what? It would be the acceleration amplitude. The amplitude of acceleration. If this is the equation, the amplitude is this part. So maximum acceleration would be equal to omega square a. So it would be 4 pi square a divided by t square. See, just to clear all these terms, let's do it through the help of a question. I think then it will get clearer. See, if I say y is equal to, that is traveling in x direction with time t, let's say it is 0.05 sine pi by 2 10x minus 40t minus pi by 4, this much. So sine's value, this much meters is the displacement. And if I ask you to calculate particle's velocity and acceleration when at, let's say, x is equal to 0.5 meter and let's say time period is 0.05 seconds. Now see, we have to compare it to the standard equation. Standard equation is what? The standard equation is the previous equation that we have seen. This equation. This is the standard equation. So we have to compare it with this standard equation. So see, for calculation of it, the equation is given to us as y is 0.05 sine. Let us multiply this. Pi by 2 is given. Let us multiply this. So it will be pi by 2 multiplied by 10x. This will be pi by 2 multiplied by 10x minus, then pi by 2 is multiplied by this also. 40t. This is open now, minus pi by 4. This is the value of sine theta. So y is what? Y is 0.05 sine. This will be 2. 2 multiplied by 5 will give us 10. So it will be 5 pi x. 5 pi x minus, this will be 20 pi t minus pi by 4. The general equation. Now see, if you have to calculate particle velocity, how will you do it? You have the value of displacement with you. So for calculation of velocity, for calculation of acceleration, you just have to differentiate it. So this is now the standard equation that you have got. Now for calculation of velocity, just simply differentiate it. Differentiate this term. For calculation of acceleration, this particle's acceleration. Differentiate the particle velocity that you will be getting. Understood how to use these equations?
Yes, ma'am.
Okay. Just in case if you have to calculate the intensity, of the wave, if you have a constant will get multiplied by the square of amplitude. Why? How I have written this? I have written is through this. Intensity is directly proportional to square of amplitude. So when we'll remove this proportionality sign, we'll get a constant. Now see, intensity is general formula. This is specifically for this wave. Intensity's general formula is basically, you have to remember this: 2 pi square f square rho v a square. This is the formula which you have to remember, memorize this formula for intensity. 2 pi square f square rho v a square. See, f is the frequency. 2 pi square f square is the frequency, rho is the density, v is again the speed of waves, and a is the amplitude. So it's just a simple formula, basic formula. And also if you have to relate it to power, because many a times intensities are directly not given, power are provided. So intensity is basically energy per unit area per unit time. So if you wish, you can write it as energy for 1 meter square area occurring or passing in 1 second, means per unit time. So intensity is energy per unit area per unit time. And energy by time is what? Power. Power is energy divided by time. So intensity will be what? Intensity will be power divided by area. Intensity will be what? Is this clear? Power divided by area. So you can also write it as energy per unit area per unit time. Find particle velocity, particle acceleration. Are these clear? Also solve this. After the class, solve this. This velocity will come out to be, I think, 2.22 meter per second something, and difference created also. Once you'll put it the values of x and t. Clear?
Yes, ma'am.
Just note it down. Particle velocity and acceleration.
Ma'am, can you scroll down?
Akifa, have you also written? Because I think you got disconnected.
No, ma'am. 1 second.
Okay.
Done, ma'am.
Ma'am, 1 minute, can you scroll down? Done, ma'am. Done, ma'am.
So the conclusion for the wave velocity and the particle velocity. See the maximum wave velocity and the particle velocity. So the maximum particle velocity is given by omega A and the maximum wave velocity. This is given by omega divided by A. So you might use this. Also, frequency is given by velocity divided by lambda. So whenever this is required, you use it. Okay, one very simple question on this only. Particle velocity and wave velocity. Equation of a traveling wave. If I give you this equation, y is equal to 10 cos 1200 t minus 3x this much meters. And I am asking you what is the ratio of maximum particle velocity and the maximum wave velocity, ratio of maximum particle velocity and maximum particle velocity and wave velocity. So I'll give you options also, just let me know. Both of you try this question. Formula is written already. First option is 30, second option is let's say 20, third option is 15, fourth is 10. Both of you send me your answers in the chat box. 1, 2, 3, 4 out of all these, which is one is coming. And note down this part also. Yes, both of you. It will be 30. Simply it will be k multiplied by a because omega will get cancelled. Fine. No. Then I don't need to discuss this. So the correct answer was 30 only. It will be simply omega a. Omega this Ka, not omega. Omega will get cancelled. It will be Ka. These two omega will get cancelled. K is 3, A is 10. This is fine. Okay. See, what all topics you have to understand is this. The first comes is the superposition principle. Superposition principle. See, in this we have three major topics. One we have is interference. Other one that we have are the waves, stationary waves or the standing waves. Stationary waves. These are also both the types. The transverse waves that I have briefed you with. And the other one is the longitudinal wave. Apart from these two, interference and standing waves, what we have to cover are the beats, formation of beats. See, superposition principle, you will be dealing this in 12th in much detail in all the chapters of the initial chapters. Basically, superposition principle means adding all the terms that are given individually. Like if I say y1 is one wave, y2 is other wave, up till let's say yn waves are there. So according to superposition principle, the net resultant waves will be the sum of all these waves added individually, y1 plus y2 up till y1. So this is basically basic definition of superposition principle. Now see, superposition principle will be covered when we will be doing all these topics in detail. So regarding interference, interference is what? Superposition of waves having same frequency and wavelength. If two waves have same frequency and same wavelength and they superimpose each other, means they give a combined resultant. They are adding up, they are added up. Then we say this phenomena is known as interference. And you will be dealing with interference, diffraction, all these processes in class 12th also when you will be studying optics. So for now, you just have to focus on interference, and all the topics that are included in your syllabus in this 11th standard is that you have to understand two equations are there. Like y1, let's say it's a sine omega t minus k of x is given. This is the first equation that is given. This is the first equation. Now let's say we have another equation, some random equation b. B is the amplitude of the second wave. B sine omega t minus kx and the phase constant phi. There's a phase difference between them, that is phi. Let's say this is the second equation. So what is phi? Phi is just reminding you this is the phase difference between these two. All right. Now see, according to interference, superposition of waves will result. Superposition will result because these are having the same frequency and the same wavelength. What is changed? Amplitude is changed. Amplitude is not the requirement for interference to occur. What is the requirement? That the frequency should be same and the wavelength should be same. You can see no difference in, I have not written omega prime t or k dash x or something like that. Both of them are same. That's why they are able to superimpose. And as I have told you, according to superposition principle, the resultant of waves is given by simply adding them. That is y1 plus y2. So in short, we can write it as the resultant amplitude of these A and B. How we'll calculate these resultant, I'll let you know. I'll remind you. You already know this, how to calculate the resultant of A and B. So let's say R is the resultant of the amplitude. Sine, the rest of the terms will remain the same. Omega t minus kx. Now we cannot directly write phi. We have to identify is actually the phase constant. We have to write the resultant of the phase difference, resultant of this phase constant. So let's not take it as phi. Let's say, because many times it may happen that it is not coming exactly as phi, it is coming as something else. So let's say it is delta plus delta. This is the resultant wave. Now let us understand what I have written, all the terms that I have written. R is the resultant amplitude. resultant amplitude. Now see, you must have done parallelograms, parallelogram law, vector addition when you have started class 11. So anyone, do you remember what is the formula for parallelogram law?
A square
Hmm.
plus 2ab sine something.
Yeah. See, if two vectors are given, if two vectors are provided, let's say A, B are the vectors, then the resultant of the vectors is given by A square plus B square plus 2ab and the phase and the difference of the angle between the diagonals of the parallelogram. So here we are not considering it as a parallelogram law, it's just a relation to it. I was just relating to it. It's not used as parallelogram law. Cos phi is the angle over here and all the term comes under bracket. So this is your parallelogram law only. A square plus B square plus 2ab cos phi. And if you remember, you must have calculated the direction also, tan theta. Tan beta, I think most of the books have written tan beta. So we are taking tan this delta. Why? Because delta I have taken as a resultant phase constant. Resultant phase constant. So let's say this is the resultant phase constant tan delta. If you remember parallelogram law, then we used to write B, then sine theta or phi, whatever is the angle, then A plus B cos phi. Yes or no? Are you able to remember? Are you able to recall this parallelogram law?
Yes,
Yes.
ma'am.
Okay, so this parallelogram law and all the basic vector laws, these will be used in next standard also, in 12th class also will be used. Okay, now see if I have to calculate the intensity. If I have to calculate the intensity, the resultant intensity. So according to superposition principle, the resultant intensity will also be the sum of individual intensities. Like if I say for the intensity of wave, if I say the first one is Ka square, as I've told you, intensity is directly proportional to the square of amplitude. This is the first one. For the second wave, I have Kb square, as I have taken B amplitude for the second wave. This is for the second wave. So resultant intensity. Resultant intensity will be what? Simply the addition of these. Added vectorically, not algebraically. Remember, if we had to add them algebraically, then we would not have been considering the vector laws. You would have simply added I1 plus I2. Here we have to consider the parallelogram law. Now see, the resultant intensity's formula is a bit different. It is not just similar to parallelogram law. Resultant intensity is given by I1 plus I2, not square and no to the power half or no under root over here. Plus 2. Now we have under root I1, I2 cos phi. So this is similar to it, but we don't have it exactly to this. See, this is quite similar. The resultant amplitude is very similar to the parallelogram because it is that only, use that only. In case of this resultant intensity, this is the final formula for resultant intensity. So if you have the intensity same, if intensities are identical, then what you should do? You should simply equate I1 is equal to I2. All right. Now see, we have two types of interference. There's not a single type of interference. One is known as the constructive interference, other one is known as the destructive interference. Now see, when do we say two waves are constructively interfering with each other, or when we say these are destructively interfering? Again, I'm telling you, you will be dealing with this concept again in 12th standard when you'll be studying wave optics. So see, if I'll tell you, let me brief you with how do we write constructive interference. because then you will be having more phenomena there in 12th standard. See, if I draw a rough diagram of two waves, let's say this is the first wave with that amplitude. This is y1. What was the amplitude that I took? I think I took A. And for the second wave, this is the second wave and the amplitude is B. See, if it is a constructive interference, both of them get added up. Both of these waves get added up. So what will happen? The resultant will be given the resultant will be addition of these. So this is the maximum value of the resultant amplitude. This is the resultant wave, YR. And R is given by what? A plus B. And the phase constant value, phi is value for constructive interference. This is 0. This starts from 2 pi, then 4 pi, and so on. So on and forth it goes. Now see, what difference will it create when we'll be considering destructive interference? You can easily identify it from this view. With the help of diagram only. Case 2 will be destructive interference, when two waves are adding destructively. Okay, one more thing. In this only I'll tell you the intensity and resultant. See, phase difference is what? 0, 2 pi, 4 pi, and so on. So how will you write it? How can you concise it? Just to remember it concisely, remember this phi is given as 2n multiplied by pi. This is given as 2n multiplied by pi. So phase difference is 2n pi. Now you can put the values of n. N will start from 0, 1, 2, 3, and so on. So you can put on different values. When you will put the value of n as 0, this phase will be 0. That's what I've written. Okay. When you will put it as 1, this will be 2 pi simply. This one. If you put it as 2, it will be 4 pi. You can write it as this. If you put n is equal to 3, then it will be 6 pi. So it will go on. So concisely, for constructive interference, phi will be equal to 2n pi. And resultant amplitude, the maximum value it will have as A plus B, because you can simply see two waves. What happens in constructive interference is that if I say this is the crest of one wave, this is the trough of one wave. So both the crests get added up and the troughs get added up. If let's say this is plus, this is plus, this is minus, and this is minus. So both plus plus are getting added. Both minus minus are getting added. That's why we say the interference or the superposition is constructive. And also the resultant intensity. Maximum value of resultant intensity will be under root I1 plus under root I2 whole square. Please understand this topic very well, because as I'm repeatedly telling you, this will be repeated again in class 12th also. You have a big portion of interference as well in standard 12. Now see, regarding destructive interference, just the opposite. If the crest gets added with the trough of another wave, destructive interference. Now see, this is for y1, the first equation. Let's say this is y1 with the amplitude A. This is the amplitude A. Now see, if two waves are adding destructively, then as I've told you, if this was plus, this was minus, just to understand, there's nothing like plus minus over here. just to understand. Here it will be coinciding with the trough of this and crest of this. And the amplitude that I took for second wave was B. So this is plus now, this is minus. These are getting added up. That's what we call it as destructive interference. So resultant, let's say this is the resultant wave. Now this will not be the maximum value because both of the amplitudes are getting subtracted. So see here in the value of phi for it will be pi, it will start from pi, it will be 5 pi and so on. How? See, for this first it will be 3 pi. After 5 pi it will be 3 pi, then 5 pi and so on. So the general formula for this is 2n minus 1 pi. So you can 2n minus 1. To n minus 1 multiplied by pi. So if I put the value of n as 1, and okay, remember one thing, that it starts from 1, not 0 in destructive interference. 1, 2, up till so on. So if I put the value of n is equal to 1, it will be 2 minus 1, 2 minus 1, that is 1 for pi. Then when I'll put the value of n equals to 2, it will be 4 minus 1, that is 3 pi. If I put it as 3, it will be 3 into 2, 6, 6 minus 1, 5 pi. 5 pi and so on it will go. So you have to remember this. This is the general formula. You just need to find the value of n and you can put it and find the value of the rest of the phase difference. So anyone can tell me what should be the value of R minimum? In case of constructive interference, maximum value of resultant was there, and that maximum value was what? A plus B. In destructive interference, if we are getting the minimum value of amplitude, what should be it?
0.
No, not 0. So it will get subtracted. In case of this, it was A plus B. In this, in destructive interference, we'll subtract it. It will be A minus B. It will be A minus B. And again, the minimum intensity, the maximum intensity was what? Under root I1 plus under root I2's whole square. In this case, the resultant intensity will be under root I1 minus under root of I2 whole square. Is this clear?
Yes, ma'am.
Okay, constructive
ma'am.
interference and destructive interference. Just note down them as well, then we'll do a question.
Can you scroll up?
Up, more up or down?
No, ma'am.
Okay.
Can you scroll down? And
Okay, let's do a question on this. Intensities of destructive and constructive interference. See, if two superimposing waves, if two superimposing waves, okay, fine, Hishma. If two superimposing waves are represented by y1 is equal to 2 sine 2 pi 10t minus 0.4x. And the other wave is 4 sine 2 pi 10t minus 0.4x. If I ask you what is the ratio of I maximum to I minimum, maximum intensity to minimum intensity, I max to I minimum. See, I'll give you options. So 36 is to 4, second option is 25 is to 9, third option is 1 is to 4, and fourth option is 4 is to 1. See how to solve it. Two waves are given to us. Now see, we have the amplitude of these waves with us. We have the amplitude of both of these waves with us. So I1 will be what? I1 will be k square of the amplitude of this. This will be 2 square. This will give us 4. For I2, it will be k square of this. This will be 4 square will give 16k. Now see, we have the value of I1 and I2 with us. Now as I've told you, I maximum is given by which formula? Under root I1 plus under root I2 whole square. So on putting the values of I1 and I2, this will be 4k under root 4k plus under root 16k whole square. So this will be what? This will be 2 under root k plus this will be 4 under root k whole square. So 2 under root k plus 4 under root k is 6 root k whole square. This is 36. Then for I minimum, it was the similar formula just with a negative sign. It was under root I1 minus under root I2's whole square. So 2 under root k minus 4 under root k. Till here it will be the same. Now from here, 2 under root k minus 4 root k. And taking the square of it, this will be simply 4k. So on taking the ratio of I maximum by I minimum, maximum is 36k and minimum is what? 4k. Ratio is 36 is to 4. Is it clear, both of you?
Yes, ma'am.
So just note down this.
Done, ma'am.
Okay, Akifa, then we'll continue in the next weekend. We'll complete this in the next year. All right, then till then revise this. This also and SHM also, because many topics were missing today's class. All right, all right.
Okay, ma'am. Thank you.